Again, we continue this example with the lone divider method for 4 players. The same scenario, it says 4 friends, Mo, Larry, Curly, and Shemp, are dividing up a set of assets S into 4 shares. The shares are labeled S sub 1, S sub 2, S sub 3, and S sub 4, shares 1, 2, 3, and 4. The table shows how each friend values the individual shares. Determine a fair division of the assets S for the friends using the lone divider method for the 4 players. So again, we have the table here that shows the shares, how each player values the shares. Again, we could see Curly again is the divider. We can tell because he values each share equally. There are 4 players, then he values each share as 1 over 4, 1 over n, 4 players, or 25%. So then as we go through here, we look for each player what they value as a fair share. Again, they're looking for at least 25%. So Mo right here, he values the first share at 31% and the third share at 34%. So these are the only 2 shares that he considers as fair shares. We go through here for Larry. The only share that's a fair share for Larry is share 4 at 40%. And finally for Shemp, the only fair share for Shemp is also share 4. 35%. So since the only fair shares for Larry and Shemp are the same share 4, then again, we have a conflict. So then the first thing we want to do is let's look at the shares for Mo. Mo likes share 1 and share 3. So again, whichever share that Mo gets can affect an optimal decision for the remaining players. So we're going to award one of these shares to Mo randomly. And again, that could be as simple as flipping a coin. So suppose we flip a coin and Mo is awarded share 1. Then Curly, the divider, we're going to do the same thing for him, except we're only going to look at shares 2 and 3 because share 4 is the one that's in conflict here. But we'll do the same thing. We flip a coin, and let's suppose that on the flip of the coin, Curly is given share 2. So again, what I like to do is, since share 1 has already been claimed, share 2 has already been claimed, Mo has already been taken care of, and Curly has already been taken care of. So just like we did similarly for 3 players, we then recombined the remaining assets here. So these are going to be recombined shares. So we simply do that by adding the value of the remaining shares, 18% and 40%. It's 58%. We do the same for Shemp, 20% and 35%. That's 55%. Then we go ahead and we use the divider chooser method. And again, because of the divider chooser method, it's always better to be the chooser. Then whoever is divider should be determined randomly. And again, that could simply be a coin flip. Now, the best that the divider can do is guarantee themselves at least half of the combined asset here. So let's suppose that Larry is the divider, then half of 58%, 29%. So Larry guarantees himself 29% of the asset. Shemp would be the chooser. Shemp is guaranteed at least 29%. If we flip a coin and Shemp is the divider, it's the same thing. He gets half of the combined asset. That's 27.5%. So he guarantees himself 27.5%, and if Larry is the chooser, he gets at least 27.5%. Either way, however this works, they're always going to get at least 25% of the original asset, the original value of the asset that we started with. Now, of course, this can be done again. Rather than Mo being awarded the first share, he's awarded the third share. And rather than Curly getting the second share, maybe he gets the first share. But whatever the results are, we recombine the remaining assets and then use the divider-chooser method. And this method works for any number of players. We've done it for 3 players. We've done it for 4 players. The same idea would be for 5 players. If there's a conflict, we go through the process of the lone divider again until we can whittle it down to 2 players. Then we wind up using the divider-chooser method. But there we go.